Good day. Now we'll be discussing the hot plate principle, parts, procedure, types, uses, and its example. So what is hot plate? A hot plate is a laboratory device used to heat sample solutions and materials uniformly without the danger associated with the open flame at precise temperatures. So in the microbiology laboratories, hot plate serves their purpose in making agar media and biochemical media. So now let's proceed to principle of hot plate. So the major component of the heating plate is electric alloy wire, and the electric effect is the only real functioning principle. So electric work involves a current flowing through an electric alloy wire that heats up and conducts heat through the outer shell. So to prevent the user from experiencing hiding problems when the electric alloy wire is in use, the electric plate is constructed using an insulating material. So now let's proceed to types of hot plates. So meron tayong dalawang major types of hot plates, the wafer hot plates and the chemical hot plates. So yung wafer hot plates have flat tops made of aluminum or anodized aluminum. So while yung chemical hot plates naman have ceramic, enamel, or aluminum tops. So both wafer hot plates or all new hot plates are explosion proof. So they are not capable of heating above 400 degrees Celsius. So now, we have also three types of hot plates depending on the design. So yung una talaga natin is yung standard hot plate. This device has a heating system. There is no stirrer. So yung function talaga ng standard hot plate nito is only to heat the solution. Yung pangalawa natin is yung hot plates with magnetic stirrer. So this hot plate has a heating element and an embedded electromagnet. So the magnetic bar or the stir bar submerged in the solution moves in a circular motion of a maximum of 2,500 RPM. And to use this hot plates is, hindi siya simultaneously. So, when you turn on, parang mag-heat ka ng solution, yung function lang talaga is mag-heat lang talaga ka. Hindi mo pwede siya na habang nag-heat ka, mag-stir ka din. Kasi hindi yun pwede in this type of hot plate. So, the third one, meron tayong yung steering hot plate. Ito yung pinaka-advanced. Sometimes ito is meron pa tong kasama na mga, mga yung external temperature sensor. Ito. So, in this model, the heating and steering components are sit-ups beneath the machine top's surface. So, mahal to siya. Pero, it gives high volume or viscous samples homogeneous heating. So, in this model or in this type of hot plate, pwede mo nang pagsabayin na habang nag-heat ka ng solution, pwede mo din siyang mag-steer ka din ng solution. So now let's proceed to the laboratory parts of the hot plate. So yung parts ng mga usual hot plate na ginagamit natin sa laboratory is yung pinakauna is yung display. Pangalawa is yung top plate kung saan yun nilalagay natin yung mga flasks natin na kung saan nandoon yung mga solution natin. So yung pangatlo, meron tayong heat control knob. Yung heat control knob helps to control the temperature. At yung pang-apat naman is yung stir control knob kung saan it helps to control the speed kung gaano ba kabilis yung pag-steer natin ng solution natin. So, now, meron din tayong mga mamahalin talaga na hot plate like sa ceramic coated hot plate, magnetic stirrer with with timer KM1, MI010205. Mahal talaga to siya na uri ng hot plate na to. So, yung pinakauna talaga na yung pinakauna na part ng kinds of type hot plate na ito is yung support clamp. So, yung pangalawa is yung external temperature sensor. So, yung external temperature sensor naman is for detecting the temperature of the liquid in the container. So, the device will stop heating when the temperature of the liquid reaches percent temperature. So, for example, naglagay ka ng support clamp doon sa sa hot plate mo, tapos nilagyan mo din ng external temperature sensor. Yung external temperature sensor kasi is nalagay yun sa liquid natin doon sa flasks. So, tapos nag-set ka yung temperature mo, sinet mo siya into 200 degrees Celsius. So, pag nag-aabot na yung 200 degrees Celsius yung liquid mo, mag-stop na yun yung device mo from heating. Kasi nga, nasisend siya ng external temperature sensor. Kaya nga sinabi ko na mas better talaga na ilagay yung external temperature sensor natin. Tapos, yung So yung pangatlo niyang part is yung cap plate. So alam natin yung cap plate is either ceramic, enamel, or aluminum. Yun doon nilalagay yung mga flask natin, yung mga container natin na kung saan nakalagay yung mga solution natin. So, yung pang-apat naman na parts niya is yung safety temperature setting. Yung nakagandahan sa hot plate na ito is meron siyang safety temperature setting. So, ano ba yung safety temperature setting? So, when the heating temperature is higher than the safety temperature, kasi yung usually kasi, di ba sinabi ko, 350 degrees Celsius lang talaga yung kayang i-heat ng hot plate natin. Hindi na siya, like, hindi, like, sabihin natin na 400 degrees Celsius, hindi na siya safety talaga na temperature. So, itong safety temperature setting, so when the heating temperature is higher than the safety temperature, the machine stops heating na. Yung panglimang part naman natin of this kind of hot plate is yung lead display. So, yung lead display is nandito mo makikita yung time, temperature, and speed. Kasi in this type of hot plate is meron siyang timer na, oo, meron siyang timer. So, yung pang-anim na part natin is yung temperature, time, and speed setting. So, yung K-freezing for time presetting and 3D digital wheels for temperature and speed adjustment. So, in this kind of, hot plate is meron tayong ipipress na timer. Like, you want to set the temperature, the hot plate na 5 minutes lang siyang i-heat or 5 minutes lang siyang i-stir, then kasama din naman ang dalawa. So, ganun yung mangyayari dito. Like, dito sa LED display, makikita mo yung pag-turn mo pag-turn mo ng temperature na, makikita mo dun sa display kung gaano ba siya kainit, yung gaanong temperature yung gusto mo. Like, gusto mo ng 200 degrees Celsius. So, ito-turn mo yung knob ng temperature, makikita mo yun sa display, yung 200 degrees Celsius. So, mag-stop ka. Tapos, dito naman sa kabila, you want to steer sa imong solution, sa anong speed gusto mo. Like, for example, 119.5 yung gusto mong speed. So, yun yung ito-turn mo din yung knob na yun into 119.5. Oh, so then kikita mo din naman 'yun sa lead. Tapos dito naman sa sa timer, i-set lang mo. May ipi-press ka na button, tapos ipi-press mo siya yung ilang gustong time, like 5 minutes, like 10 minutes, it's up to you na. 'Yun yung mga parts ng hot plate na to. Medyo mahal nga siya, pero mas mainam naman siyang gamitin compare sa ibang mga hot plate natin. Like for example, sa standard hot plate natin na hindi siya mag-stir, yung function lang talaga niya is solely for heating the solution, like yung sa magnetic stir hot plate natin naman na, oo, may pwede siyang mag-stir na solution, pero hindi naman talaga siya like sabayan yung pag-function niya. Like, una mong gawin is mag-heat lang ka lang, tapos pag matapos ka na mag-heat, other time naman na mag-stir ka ng solution mo. Pero in this kind of hot plate talaga is mas advanced siya at mas efficient siya gamitin at mas madali siyang gamitin, pero mas mahal nga lang. Let's proceed to procedure of using a hot plate. The first procedure is make sure the workspace is organized and spotless. Second, place the hot plate on a level, flat surface. Number three, ensure that the instrument is clean and dust-free. Tapos, yung ikaapat, attach the power cord to the required power supply. Pero, kailangan yung power cord natin is hindi siya naka-attach doon sa top plate natin kasi nga mainit yon. Tapos, there's a possibility na masunog or madamage yung power cord natin. Number 5 is fill the solution to be heated in the vessel and place it on the top of the hot plate. Pero, kailangan na yung vessel or yung beaker or flask natin is malagay natin siya talaga sa gitna. Kasi pag hindi natin siya malagay sa gitna, there's a possibility na mahulog siya at masira. Yung pang-anim natin is ito turn clockwise natin yung heat control knob natin into our desired heat setting. So, pagkatapos nun, we need to enter the magnetic stirrer naman sa flask natin. Kasi when we turn on or turn clockwise the stir control knob, hindi ho yun mag-stir yung solution natin sa vessel natin kung wala siyang magnetic stirrer. So, kailangan natin before we turn on the stir control knob is nalagay na natin yung magnetic stirrer natin. After we reach the desired heat setting and stir setting natin, is we need to get or retrieve the magnetic stirrer inside the flasks or the vessel using the magnetic stir bar retriever. So, before natin siya i-switch off. Tapos, ngayon, if yung hot plate natin is mas advanced talaga siya, meron siyang kasamang stand clamp and external temperature sensor, yung kailangan natin gawin is, i-set up muna natin yung stand clamp and yung external temperature sensor before natin before natin yung power cord isaksak sa may saksakan para hindi ho tayo makuryente.
Let's move on to the example of laboratory hot plate. So first, the laboratory hot plate CRC, this Progretti SRL. Ito siya. Ito. So it is an extractable heater, comprises a stainless steel tube and an armored heating element. It's also called fibro ceramico refractario, a technological substance is used for room installations. Fully functional electrical panels with control and safety mechanism, or thermocouples and programmable digital electronic instrument. Second is this the laboratory hot plate MBHPL 400 M brown. So these are under specific process circumstances. The M brown MB HPL 400 vacuum hot plate is intended to cure delicate organic layers. Application included everything from simple research to complex productions procedures. Next is this the laboratory hot plate EW04805 series, so also known Stuart equipment. It is the Stuart UC150 and US150 hot plates that are made of either chemical resistance, glass or ceramic or the coated aluminum silicone. So this device have integrated LED setting scales that display temperature measurement in degrees Celsius, flashing hot warming indicators that flash when temperature exceed 50 degrees and small overall design. And next this the laboratory hot plate RC series or the Valve Scientifica. So these are the excellent chemical resistance that uniform heat distribution, coated aluminum alloy, heating plate and a maximum temperatures of 370 degrees. Also, it holds flash up to 15 liters in capacity. Next, last of the example laboratory, this one, the laboratory hot plate DH point WHP series, or also called WITEG, Laborotechnic GmbH. These are the two featured, the close coverage types and the intelligent fluid management system, which direct accidentally spilled liquid away from the device interior, protect the device against internal corrosions, and extend its lifespan. Also, it's ideal for applications requires high temperature in the lab, such as the sample drying and the general heating. Let's proceed to the use of hot plate in microbiology. So, the number one is making agar media and the biochemical media. These are hot plates are used in microbiological laboratories to make agar media and the biochemical media. This is an essential step in the process of detecting, culturing, and identifying microorganisms like the bacteria, fungi, viruses, and etc. The next, the heating glassware and its components. These are the hot plates are used to heat glassware and its components in a laboratory setting. This is useful for various microbiological processes that require heat. And next is the heating sample. Hot plates are used to heat samples for the variety of purposes, including the evaporating solvent, melting solid, and sterilizing media. So they are commonly used in chemistry and biology laboratories to heat samples for various purposes. And next is the maintaining constant temperature. These are the hot plates can maintain a constant temperatures, making them ideal for growing cells or cultures. They are frequently used in biology and microbiology labs to culture and study microorganisms, then providing a sterile environment for growing cells or the culture. Next is the sterilizing equipment. These hot plates can be used to sterilize equipment such as the glassware, instruments, and other materials. So this is the particularly important in microbiology laboratories where maintaining a sterile environment is crucial. And last is the ensuring, and not hindi pa pala last, ensuring homogeneous mixing of sample. These are hot plates are used to ensure a homogeneous mixing of sample prior to analysis. So this is the important in ensuring the accuracy and reliability of laboratory results. And these are the last, the preparing samples. The hot plates are used in the preparation step before the extractions and purification of different macromolecules or like protein, mostly nucleic acid, and lipids. So these are the important steps in the analysis and identification of microorganisms. Next, let's discuss about the precaution of using hot plate, advantages and the limitation. So let's go to the precautions of using hot plate. So first is use caution if a spark is seen, the plug or cord is worn, frayed or broken, or the grounding pin has been removed. So next is never store flammable substances or combustible material next to the hot plate and use holder or older hot plates sparingly for flammable material. So the next is check the thermostat for corrosions, which can also result in spark. Unplug the device while not in use. Use only borosilicate glassware that can withstand heat and inspect it for cracks before heating. Never put jar, soft glass, or glass flask directly on hot plate. Make sure the ha- make sure the make sure that the plate surface is bigger than the item being heated. And last is never use hot plate to heat foil or metal spans because the spark and surface damage are both possible effects. Let's go. Let's go to the advantage of hot plate. So the number one is the hot plate are relatively affordable. Two is the hot plates are conveniently portable. Third is that they are enable several vital laboratory processes. Fourth is they are quietly simple to use, and last is that since they don't employ and movable mechanical parts, the hot plate stirrer are less susceptible to wear and tear. And let's go to the limitations of hot plates. So the hot plates are frequently used in laboratories. However, they can be dangerous since they can produce burns, fire, and electrical shock, which can result in accident, seriously disrupt lab work, and destroy scientific data.
Good day everyone! Today I'm going to discuss about the spectrophotometer, the parts, the uses, and how it works. What is a spectrophotometer? It is a laboratory equipment that can measure the number of photons or the intensity of light observed after passing through the solution sample. And in addition, it can also detect the concentration of the solution by measuring the intensity of detected light. Spectrophotometer consists of two different devices. One is the spectrometer, which the one who emits the light of the desired wavelength, and the photometer, it detects the amount of light absorbed by the solution. Now, let's move to the different parts of a spectrophotometer. First, we have the light source, or commonly the tangent lamp, which provides a visible spectrum of light in a spectrophotometer. We also have the lens that collects the radiation from the source and directs it into the slit. We also have the monochromator, help in dispersing the incident ray of light. We also have the sample solution placed in a cuvette or glass tube sample holder. And of course, we have the slit that provides us narrow image of the radiation and selects the desired spectrum of the light emitting. And last but not the least is the digital display or meter where the readings occur. How does a spectrophotometer works? A lamp provides the source of light. The beam of light strikes the diffraction grating, which works like a prism, and separates the light into its component wavelength. The grating is rotated so that only a specific wavelength of light reaches the exit slit. Then the light interacts with the sample, and from this point, the detector measures the transmittance and observance of the sample. Transmittance refers to the amount of light that passes completely through the sample and strikes the detector, while the observance is a measurement of light that is absorbed by the sample. The detector senses the light being transmitted through the sample and converts this information into a digital display. Now, let's move on to the uses of the spectrophotometer in a microbiology laboratory. So first, we have the quantification of microbial growth, where spectrophotometer is used to measure the growth of microbial cultures by monitoring changes in optical density over time. This can help the researchers determine the growth rate of microorganisms and assess the effectiveness of the antimicrobial agents. Then, next second is the determination of the bacterial concentration, where spectrophotometer can be used to estimate the concentration of bacteria in a sample by measuring the observance of light of a specific wavelength. Third, we have the identification of bacterial pigments, where some bacteria produce pigments that can be detected and quantified using the spectrophotometer. Then this can be useful for the identifying microbial species and studying their metabolic activities. And last but not the least is the analysis of microbial metabolites, where the spectrophotometer is used to analyze the production of metabolites by microorganisms, such as the enzyme, the toxins, or other compound.
Hi ma'am, good morning or good afternoon. Now that my groupmate has provided the overview of spectrophotometer, I am assigned to tackle and discuss the working mechanism of spectrophotometer and how it is used. I will also tackle its preventive measures and its various types. So in this overall presentation, we will explore the significance of its scientific use in research and analysis. So let us first discuss the working mechanisms of spectrophotometer. So when using spectrophotometer, it requires the calibration of the machine using the standard solutions of known concentration. Depending on the solution, a specific wavelength of light is selected for the test. The ray of light passes through the diffraction grating. Then the mirror is for the light navigation in the spectrophotometer, while the prism splits in the light into different wavelengths. So the light diffraction grating allows only the desired wavelength of the light passes through it. Then the light reaches the cuvette with the solution, which is the test standard. So when the monochromatic light reaches the cuvette, some are absorbed, some are reflected, and some are transmitted. Then after that, the photodetector system detects the transmitted light, which measures its intensity and converts it into electrical signals, which is sent to galvanometer. Now the galvanometer measures the received signals and displays it into digital form, which is in this way it is absorbance of the solution. So the concentration of the solution is calculated after the determining of the absorbance by using this formula, which is shown on the screen, where A is the absorbance, C is for the concentration of the solution, and L is the path length, and this sign is the molar extinction coefficient. Then a simple exception of a double beam spectrophotometer is that the monochromatic light splits into two beams. One is for the standard solution and the other is the test solution. So in this type of spectrophotometer, the processing of the test and the standard solution occurs simultaneously. And after that, I will now discuss how to operate the spectrophotometer. So first, power on the spectrophotometer. Plug in and power on the device, allowing it to warm up for 5 to 15 minutes depending on the model. Second is select the wavelength. Find the wavelength knob and rotate it to set the desired wavelength. Different compounds absorb light at different wavelengths, so it is essential to choose the appropriate wavelength for your specific experiment. And after that, adjust the filter wheel. Set the filter wheel to the corresponding filter for your chosen wavelength. Like for example, use the violet filter for wavelengths between 300 and 375 nanometer. Blue for wavelengths 375 and 520 nanometer. Yellow for wavelengths between 520 and 740 nanometers. And red for wavelengths 740 to more than 900 nanometer. Next, set the mode. Select the mode that displays percent transmittance or percent absorbance depending on your experiment requirements. Then, prepare the sample chamber. Ensure the sample chamber is empty and closed. Adjust the zero control knob to read 0. and don gloves to wipe a blank cuvette with a lab wipe before inserting it into the sample compartment. Adjust the light control knob to read 100. And after that, insert the cuvette. Replace the blank cuvette with a sample cuvette. Record the value shown on the meter. Next, calibrate the instrument. Every time the wavelength of light is changed, the instrument must be recalibrated to read 0% T or 0.00 A with a blank. Repeat steps 2 to 5 as needed. And remember, to clean the cuvette and ensure they are free of any particles, smudges, or fingerprints, as these can affect the machine's calculations. And also, be mindful of the sample chamber's position and avoid leaving the chamber or test tube's access doors open. Lastly, I am going to discuss the preventive measures when using the spectrophotometer. So firstly, the spectrophotometer should be turned up to 10 to 15 minutes before use. Then, second, the device should be calibrated each time. And third, the selective wavelength should not be maximum wavelength that the solution can absorb. Then, the sample should not contain any substance which can dissociate or react or change during the measurement. And lastly, since the absorbance depends on the concentration sample, preparation should be within the acceptable concentration range. And that's all for the preventive measures when using the spectrophotometer.